Science seeks to understand the universe, it asks questions and seeks answers. But to unlock the secrets of nature, we need more than just curiosity. We need tools, we need instruments that extend our senses, amplify our observations, and allow us to probe the very fabric of reality. These tools are scientific apparatuses. Scientific apparatuses are the instruments, equipment, and tools used in scientific experiments and observations. They range from the simple, like a graduated cylinder or magnifying glass, to the incredibly complex, like particle accelerators and electron microscopes. Each apparatus serves a specific purpose, designed to measure, analyze, manipulate, or observe the world around us. These instruments are our eyes into the microscopic world and our ears listening to the symphony of the cosmos. They are the hands with which we dissect the complexities of nature, revealing the intricate mechanisms that govern our universe. The evolution of scientific apparatuses is intrinsically linked to the advancement of science. As our understanding of the universe deepens, so too does our need for more precise, sophisticated, and specialized instruments. The history of scientific apparatuses is a captivating tale of human ingenuity, stretching back to the dawn of civilization. It is a story that reflects our relentless curiosity and our desire to understand the world around us. From the earliest days, humans have sought to measure, observe, and experiment, using whatever materials and knowledge were available to them at the time. From the simple tools used by ancient astronomers to chart the stars, such as rudimentary star charts and basic observational instruments, we see the beginnings of a long journey. These early astronomers, often working with limited resources, laid the groundwork for future generations of scientists. To the sophisticated instruments employed in modern genetic engineering, the evolution of these tools mirrors our quest to comprehend the world around us. Today, we have advanced technologies that allow us to manipulate the very building blocks of life, showcasing just how far we have come from those early days. Early civilizations relied on rudimentary instruments. These tools, though simple, were revolutionary for their time. They enabled early humans to make sense of their environment, to predict natural events, and to navigate their world with greater confidence. The Egyptians used sundials to measure time, a practice that was crucial for their agricultural and religious activities. The ability to track time allowed them to organize their society more effectively and to align their activities with the cycles of nature, while the Greeks developed astrolabes for navigation and astronomical observations. These instruments were not only practical tools, but also symbols of the Greeks' advanced understanding of geometry and astronomy. These early apparatuses, while simple by today's standards, were groundbreaking in their time, laying the foundation for future scientific exploration. They represent the first steps in a journey that would lead to the sophisticated technologies we have today. The Renaissance marked a turning point. This period saw a resurgence of interest in science and learning, driven by a renewed curiosity about the natural world. Scientists and inventors of the Renaissance began to question old assumptions and to seek new knowledge through observation and experimentation. The invention of the printing press facilitated the dissemination of knowledge, making scientific texts more accessible and allowing ideas to spread more rapidly than ever before. This democratization of knowledge was a key factor in the scientific advancements of the time, while the development of lenses led to the creation of telescopes and microscopes. These optical instruments opened up new worlds for exploration, from the distant stars to the tiny organisms that inhabit our planet. These instruments revolutionized our understanding of the cosmos and the microscopic world, respectively. Galileo's telescope allowed us to see the moons of Jupiter and the phases of Venus, challenging the geocentric model of the universe. Galileo's observations with the telescope challenged the geocentric model of the universe, providing evidence that supported the heliocentric theory proposed by Copernicus. This was a pivotal moment in the history of science, as it fundamentally changed our understanding of our place in the cosmos. While Leeuwenhoek's discoveries with the microscope revealed a hidden world teeming with microorganisms, his observations laid the groundwork for the field of microbiology, opening up a new frontier in the study of life. The Industrial Revolution ushered in an era of unprecedented technological advancement. This period saw the development of new materials and the invention of machines that transformed industries and societies. The development of electricity, magnetism, and new materials paved the way for the creation of increasingly complex and precise instruments. These innovations enabled scientists to explore new phenomena and to make discoveries that were previously unimaginable. From spectroscopes that analyze the composition of stars, allowing us to understand the elements that make up distant celestial bodies, to X-ray machines that allow us to peer inside the human body. These innovations have transformed our understanding of the universe and ourselves. Each new instrument has opened up new possibilities for exploration and discovery, continuing the legacy of human ingenuity and curiosity. Scientific apparatuses are indispensable to the scientific endeavor. They are the bridges that connect our curiosity with the mysteries of the universe. They are not merely tools, but extensions of our senses, allowing us to perceive the imperceptible and understand the incomprehensible, enabling us to explore realms beyond the limitations of human perception. From the microscopic world of cells to the vast expanse of the cosmos, these instruments are our windows to the unknown. Their significance lies in their ability to enhance our observational capabilities, improve measurement accuracy, and facilitate the manipulation and control of variables, thus forming the bedrock of scientific inquiry. Without them, our understanding of the natural world would be severely limited. Imagine trying to study the cosmos without telescopes. These powerful instruments have revolutionized our understanding of the universe. We would be limited to naked eye observations, oblivious to the vastness and complexity of the universe. The night sky would appear as a mere scattering of stars, hiding the true wonders that lie beyond. Telescopes extend our vision, allowing us to peer deep into space and time, observing distant galaxies, nebulae, and the remnants of stellar explosions. They reveal the intricate dance of celestial bodies and the birth and death of stars. Consider the study of microorganisms without microscopes. These tiny life forms, invisible to the naked eye, play crucial roles in ecosystems, human health, and disease. Microscopes reveal this hidden world, allowing us to observe the intricate structures of cells, identify pathogens, and develop life-saving treatments. They have been instrumental in advancing medical science and improving public health. Microscopes reveal this hidden world, allowing us to observe the intricate structures of cells, identify pathogens, and develop life-saving treatments. They have been instrumental in advancing medical science and improving public health. Scientific apparatuses not only expand our observational capabilities, but also enhance our ability to measure phenomena with precision and accuracy. This precision is essential for the reproducibility of experiments and the validation of scientific theories. Precise measurements are crucial for scientific rigor, allowing us to quantify observations, establish relationships between variables, and test hypotheses. They provide the foundation upon which scientific knowledge is built, enabling us to unlock the secrets of the universe. The absence of scientific apparatuses would be akin to navigating a labyrinth in complete darkness. Imagine trying to find your way without a map, a compass, or even a flashlight. Every step would be uncertain, every turn fraught with potential danger. This is the reality we would face without the tools of science to guide us. We would be deprived of the tools necessary to illuminate the unknown, to unravel the mysteries that surround us. These instruments are not just tools, they are extensions of our senses, allowing us to see, hear, and understand phenomena that are otherwise beyond our natural capabilities. The consequences of such scientific blindness would be profound, impacting every facet of our lives. From the food we eat to the technology we use, every aspect of modern life is touched by scientific discovery and innovation. Without telescopes and other astronomical instruments, our understanding of the cosmos would be severely limited. We would be confined to the knowledge that our ancestors had, unable to explore the vastness of space or comprehend the complexities of celestial bodies. We would be blind to the vastness of the universe, unaware of the existence of other galaxies and the intricate dance of stars and planets. Our curiosity about what lies beyond our own world would remain unfulfilled, and oblivious to the awe-inspiring phenomena that occur beyond our planet. Supernovae, black holes, and the birth of new stars would be mysteries we could never hope to solve. Our place in the cosmic tapestry would remain a mystery. Our understanding of the universe's origins and our own existence would be severely limited. We would be like sailors lost at sea with no stars to guide us, our perspective confined to the narrow confines of our own world. We would be unable to appreciate the fragility and uniqueness of our planet in the vast expanse of space. In the realm of medicine, the absence of microscopes, imaging equipment, and diagnostic tools would render us powerless against disease. Our ability to understand the human body and its ailments would be drastically reduced, and diagnostic tools would render us powerless against disease. We would be unable to detect illnesses in their early stages, making treatment more difficult and less effective. We would be unable to identify pathogens, diagnose illnesses, or develop effective treatments. The progress we have made in combating diseases like cancer, HIV, and countless others would come to a standstill. The advancements we have made in combating infectious diseases, understanding human physiology, and extending lifespans would be unimaginable without these vital tools. Our quality of life would be significantly diminished, and extending lifespans would be unimaginable without these vital tools. The elderly and vulnerable would suffer the most, as medical care would regress to primitive methods. Furthermore, the lack of scientific apparatuses would stifle technological innovation. Our ability to create new technologies, improve existing ones, and solve complex problems would be severely hampered. The development of new materials, energy sources, and sustainable solutions would be hindered. Our progress towards a more sustainable and efficient future would be stalled, and communication technologies relies heavily on our ability to study and manipulate matter at the atomic and subatomic levels. Without these capabilities, the advancements in nanotechnology, quantum computing, and other cutting-edge fields would be impossible.